Hello students, in this video we'll begin our study of second-order linear differential equations and discuss some basic properties of them. A second-order linear ODE has the form a of x y double prime plus b of x y prime plus c of x y equals r of x. And we'll say that this equation is called linear. So linear implies that the coefficients of y, y prime, and y double prime only depend on x. So we have a c of x, a b of x, and an a of x. There's no expressions that involve y as any of those coefficients. Now we have an important subcase to consider. There are two cases. If r of x is equal to 0, the right-hand side is equal to 0, the equation is called homogeneous. If r of x is not equal to 0, the equation is non-homogeneous. Now we can use the following fact. This is called the principle of superposition. The principle of superposition says that if you're given two solutions of the homogeneous equation, and so by homogeneous, remember that means that the r of x is equal to 0. So if we're given two solutions of the homogeneous equation, I'm going to drop the of x's and just assume that of x's. A y double prime plus by prime plus cy equals 0. We'll call this equation star. If I have two solutions of the homogeneous equation, r1 and r2, or y1 and y2, then for any constants, c1y1 plus c2y2 is also a solution. Meaning that if we find two solutions of the homogeneous problem, we can take any combination of them we like and get another solution. So for example, we could have 5y minus 3y2, or negative y1 plus 100y2, or 50y1 plus 0y2 would be another example, or 0y1 minus 7y2 are all examples of linear combinations of y1 and y2. A constant times y1 plus a constant times y2. And the proof of this is straightforward. What we do is we say we have a, and then c1y1 plus c2y2 double prime, plus b, c1y1 plus c2y2 prime, plus c, c1y1 plus c2y2. We'd like to know if this is equal to 0. Well, what we'll do is we'll split the terms into two. We will say that this is going to be a c1y1 double prime plus b c1y1 prime plus c c1y1. Those are this term, and this term. And then we'll do the other terms next, plus a c2y2 double prime plus b c2y2 prime plus c c2y2. And those are these terms over here. And all of those yellow terms will add up to 0 because y2 is a solution. So the yellow terms are equal to 0 because y2 is a solution. I can pull out a c2 from all of them. And the pink terms are 0 because y1 is a solution. So that gives us the following result. So it gives us our proof that once I have two solutions, any linear combination of two solutions of the homogeneous problem will also be a solution. And the theorem that we also have is that a general solution of star of our homogeneous problem has the form C1y1 plus C2y2, where y1 and y2 are linearly independent solutions. So once you find two linearly independent solutions of a non-homogeneous second order ODE, the general solution is formed by taking a linear combination of those two solutions. Thank you very much.